This demo highlights features and capabilities that we have coming in HPE Supercomputing Management Software Foundation, or SUMS Foundation for short. SUMS Foundation has a variety of features to help system administrators understand hardware inside and out. This command displays all controllers and their types in the system, enabling system details to be reviewed at a higher level with a bird's eye view. GX management controllers are added to the SUMS Foundation database with the appropriate type to represent the physical hardware and the function they serve. GX controller host names begin with an X and denote the location and component type within a GX rack. Now let's focus on all controllers within a single X5000 rack. Within a rack, controllers represent different hardware types at different levels. At the rack level, we have the top of rack controller, the torque, the X5000. We also have the rack slots S1 through S36, including the compute blades, the blade controllers, and the compute nodes, as well as the switch chassis enclosure, including the slingshot components, switch chassis controller, the StarKist, the switch controller, and platform controllers. To see the associated compute nodes for each blade controller, we use the following command. This command shows the power status of all blade slots in the racks X5000 and X5001 via their torque controllers. The system includes a mix of ILO, XD, and GX hardware. To identify the controller type for each node, we use the following command. At the top we see an XD295B and an XD665, followed by the GX computes. The GX computes have early firmware, and therefore limited information to show at this time. Now let's check the power status of all GX nodes. As the number of racks, blades, and nodes increase, text-based status output can become more difficult to read. We've found that many system administrators prefer a visual representation, for example, to gain insight into patterns based on locality while still maintaining the command line interface. We can export the power status output to the rack map visualization tool. This display shows the state of each blade in both racks. The legend indicates the state of each node. The green arrow indicates which nodes are booted, the blue O indicates nodes that are powered on, and the red slash indicates nodes that are powered off. Image management and node provisioning are critical pieces of SUMS Foundation to get nodes set up with foundational software, including the operating system, and prepare them to carry out workloads. The following commands show the available images and which image is assigned to each node. In this case, we have RHEL 9.6 and RHEL 10.1. Now we'll provision a node with a new image. We'll check the current image assignment, stage the image with an iSCSI root file system, verify the staging, and then power cycle the node to boot into the new image. All provisioning steps can be carried out on one or many nodes. First, we'll check the currently assigned image, which shows as RHEL 9.6. Now we'll assign an image to the node and stage it to be provisioned on the next boot. Next, we'll verify the image. And then we'll power off the node and verify the power status. Next, we'll power on the node to boot into the new image. And we can now transition to the console window to see that the node is PXE booting. Now that the foundational software has been provisioned, we can examine the nodes to ensure they're set up correctly and ready to run workloads. SUM's foundation includes cluster-wide command execution capabilities, so we'll be running commands across multiple nodes simultaneously. To check that the OS version was provisioned successfully across all GX nodes, we'll use the cmnode run command. The commands demonstrated up to this point were running in a completely virtualized cluster with Redfish emulators created for the GX, XD, and Odlo hardware. Now let's transition to real hardware. Performance in the real environment may vary from that in the emulated environment, but the code is the same and will carry out commands in the same way. Arctic is an actual GX system currently under construction, with new hardware being inserted as it's assembled. The rack map summary and legend denote the different node power states. As you can see, the real hardware has a variety of node states, including nodes that are booted, nodes that are on, nodes that are off, and nodes that are currently unreachable. Thank you for watching the HPE Supercomputing Management Software Foundation demo.